Alrighty, we are live for part 3 of the Synacor challenge. Um, so last we left off, we just got the VM running and we were able to print the Synacor welcome message. And it looks like from here on, we're going to have to make sure the self-test is working and passing properly. So, probably have bugs. Yeah, I made my terminal all Synacor themed. I did it with my editor too. I don't know if that's too much, but we've gone full Synacor. So I think maybe as a quick warm up, well, let's look at our wish list. So I've been adding things to the README. I'll leave that link in chat. The biggest thing we need to do is implement the encode. But before that, it seems like our self-test is still not working. It might be because of the encode, but we'll have to debug. And then once we get our encode, we'll get some sort of interface for entering input into the running VM from our keyboard. So still kind of have to think about how I want to do that, but that'll all come together later. Oh yeah, you asked, what have you been listening to for the stream background music? Oh yes, so this is Tokyo Synthwave, or Synthwave Tokyo rather. I can drop a link to their channel on YouTube Music, but I think they're also on Spotify. So my music's in theme. Had to theme up for this one. All right. And then I have some other little wish list things that we talked about. So type params for valid state transitions. This wouldn't really do much except prevent us from making future bugs. It might help us find whatever the current bug is. So maybe we'll do that as kind of a warm up as people get in. It shouldn't take long. And we could use a state monad and a transformer. That might come into play as we're doing the interface for input, like some reader-writer combo. And then nice error types. That might just happen organically as we're trying to debug things and need more information. Yeah. So let's start off by going here to our VM state and looking at the general way these helpers are called. So usually we'll do something like store a value, or like, I don't know, we'll do some mutation of the state, so the memory or the registers or the stack, and then we'll move the counter, and then we will excuse me, and then we wrap up our output and make sure that our types are all wrapped. So then we wrap and package and we get ready for the next tick. So I want to grow this slowly so we don't get too bogged down in details, because there's a lot you can do with a finite state machine in the type system with Scala. And even what I'm about to do, there's multiple ways to do this. Search terms for this would be, let's see, phantom types, just as if anyone's interested. There's phantom types, or there are erased values in Scala. So those are both efficient ways to do this just in a type system that prevent you from calling methods that you aren't supposed to. So I'm going to do a type. So we have our VM state. It has certain phases when it's running through an instruction, right? So I'm just going to call this the phase. Or, we'll make it a trait. So it's a sealed trait phase. And then for now, let's just have a ready. So type ready. I like it. So It could be a type alias. I think it could also just be a class. We're just gonna say type ready. Nah, class. Class ready extends phase. And then we'll have class. No. We're gonna make these type aliases. So type ready is just gonna be some subset of phase. You know what? I'm not actually sure how I wanted to do this. Yeah, okay. We're gonna back off on that. Maybe we can undo that comment later, but we'll do this as a class. Class ready extends phase and class. What do we have? So we're ready to do our work. We do some sort of work, we progress the pointer, and at that point, we can do the output. So we could say after we've moved the pointer. So PC moved. We'll just shorten it to moved. Okay. So now a VM state has a type parameter p, which gives us its current state, and this will be some subtype of phase. Now we could make some type functions here that make things more readable. Let's say we'll make a type function for can move, I suppose. So, or can update. So we can start updating state if we are ready. So given a p, which is a phase. Oh, I want to turn that off. What it's trying to make for me is some sort of a type lambda, but we don't need a type lambda here. I'm going to toggle the suggestions. And we're just going to do some evidence that p is equal to ready. Okay, so we can update when we are ready. Or, this could also be a subtype. Maybe we'll say subtype for now, because we might have multiple ways that you can update. Or be ready, I don't know. And then the other thing we'd want to ask is we can progress, or I guess we can go back to the ready state, right? So yeah, I'll call it can progress. Can progress. And that is true if we have already moved or updated. Maybe I could use better language there. But the point is we have two types that we can switch between. Now I should start getting errors here. No, not yet. Okay, so a function like progress. It's going to return a VM state of updated. So our state has a state. And in order to run it, we'll need evidence that we can update. Is that what we had? Can update p. And that's just done with using that. Now, this dot copy next instruction, sure, that makes sense. And then jump is going to be much the same thing. In fact, I'll just copy this bit over. Okay, so it also requires that we can update. And then storing is the same kind of thing, also can update. So I might even just do a find and replace. A teak with buck teeth from YouTube. Hello. So we'll just put these after all of these methods because they're all pretty much going to return the same thing and take that same requirement. In fact, there's probably an even nicer way. So with Scala 3, there are types, meaning a context function. So a context function is like a type function from a, a contextual parameter like this using to an output type. So I could actually make a type parameter for just this whole thing. You know what? I might want to do that. So what would it look like? I suppose I don't know. We'll leave it more explicit like this for now, and then that's not something I've used much, so we'll think about that refactor later. YouTube suggested me to you randomly. Oh, that's funny. Are you why might that be? Are you much of a programmer, or did you do Advent of Code? So I'm doing this project because Advent of Code just finished, and it finished early this year. So this is another Eric Wastl puzzle, um, and I'm continuing the season with this project. Okay, this tick. This is not going to take a type parameter, so because the VM state needs a type parameter, right? So there's going to be a P, which is a subtype of phase, and we add that to our VM state. The argument does not have the same kind as its bound. Oh, does it not really? The argument Synacor.vm state does not have the same kind as its bound. Oh, you know what? Let's just not give it a kind there. We can just give it that type parameter. Okay, yeah, that works. Okay, so I'm just adding these restrictions to all of our like state progressing functions. So progress, jump, store in a register is doing kind of the same thing. And then we've got push. And then pop is not really progressing. I guess it is progressing the VM state. So it needs a type parameter. So using can update p, and then VM state goes to updated. We learned HTML and CSS 2 years ago. Fair enough. It might be a little bit harder to keep up here, but I try to explain it. Okay, so our step, so we should only be able to step when we're ready to take in a new instruction code, right? So we'll give some evidence that we are ready. What did we use? I don't think I like the name we moved. So can progress. I could say like has updated or can, I'm just gonna say can ready. It can. No, I guess we have can update. Yeah, probably need a better vocabulary for that. So we are ready when we can update. So when you update our type P here, and then the end result should be we go back to ready. So we go through a couple states, but we always end up back at ready. In fact, you know what? I think it might be clear to say something like P is ready. So it starts at ready and it ends at ready. So maybe I should rename that to like is ready. Yeah, I think I will rename it to is ready. Okay, great. Now we just start getting type errors in here somewhere. No? No worries, don't worry about it. I hope you have a good night. So we are missing a type parameter for a synacor.tick somewhere. No output. Ah, right. So this is a tick. Once we do all the outputs, we go back into a ready state, right? And we are ready to do that when we have progressed. Yeah. Basically, we are already in the move state. So let's say, I don't know about can progress. Let's just say has updated. So has updated. Or, has moved. We'll call it updated for now. But basically, it means our current state is, or our current phase is moved. And I'm going to rename this can update to is ready. Symbol. Okay, so we're ready for the next instruction. It's ready with, or no, we're replacing can update. Can update is ready. No, not can update. There we go. Okay. Great. I think that makes more sense to read. So when we have no update, we'll say, or no output, we'll say we have updated. So using has updated our current phase. And then we'll tick to a ready state. Oh, and similarly here. Oh, hey, I must not be getting my Twitch notification seem disconnected. So I haven't been hearing chat. But hello, Sparkly Dark Matter, welcome. And Zuno, what did you miss? What did you miss? Basically just kind of did a quick recap of where we are. And what we're doing right now, as a kind of little side digression, it shouldn't matter much in the implementation, but maybe it'll prevent us from catching bugs. I'm just adding a type parameter to our VM state that tells us the current phase, so that some methods are illegal to call if you're not in that current phase. So basically, the idea is that we always do an update, and then we always move the pointer, right? So this enforces that before we go to another update, we first move the pointer, and that forces a compile time. It's a compile error if we forget to move the pointer like we did. Yeah, so output using same thing. So once we have updated, is legal to output. And WFM Macaw, good to see you again. I appreciated your help debugging yesterday. Yeah. Can fetch instruction. That's a good idea. Let me just reconnect my chat here real quick because I didn't realize people were chatting to me. Yeah, can fetch instruction. That's a great idea. I like that's descriptive. What color theme is this? So I did two things with color themes. So this one is called CRT Matrix in VS Code. I wanted to match up with Synacor, obviously. And then I also did something in my terminal to make it more, I don't know, to make it more similar. So I just used various shades of green, and I just kind of had ChatGPT help me figure out reasonable colors. Oh, okay, that's a random U in there. Um, it's a little bit less legible, but I think we can live with that for now. Like there's still some highlighting. I don't know, maybe it's too much. Maybe it shouldn't all be the same color theme, but I'm enjoying it for now. So CRT Matrix was the name of that. That's to, oh yes, the usual stages of CPU execution. Right, I should just use that. Fetch, decode, read, ALU, write, uh, and all that in a loop. Side side note. So when I was in college, I had an architecture class, and we had like a five state. Um, I think it was based on MIPS. They were calling it tepid, which is oh, I think maybe it's based on like warm. It was like some ARM architecture. So we had to like make an implementation of that, and it turned out I was able to simplify it a lot and not do five stages and just do a two-stage clock. And that just greatly simplified everything, and it was still to spec. I mean, it was like the opposite. It was like the opposite optimization. You could have also optimized it and like added parallelization and tried to make it faster, but you could also just greatly simplify the circuits and do everything in a two-cycle clock. So that made it easier to read, easier to implement. I had fun doing that. But yeah, um, can fetch. Can fetch is a great name. So we'll just leave it at that. And thanks. I'm glad you like the themes. So we will tick to a ready state. We can do like a find and replace on those names later. I think sometime while we're talking, I might just need to restart VS Code because I'm feeling the lag from something. I know, probably the instance from yesterday still running. So whenever we're outputting, we make sure that things have updated. The thing is, we aren't always going to memory necessarily, right? We aren't forced to like check the registers and then go to memory and whatnot. We might just do one or the other. We might do none at all. Like we might just straight up jump. And then when we progress or jump, so these are both states that move the pointer. Same thing. We need to be ready. Or actually, you know what? This can happen sort of from any state, can't it? I think this should be basically update or up. Let's make a new method here. Let's say can move. So we can move a pointer if our current state is let's do it this way. So sometimes you can just jump straight to moving a pointer, right? Like with the jump method in particular. So let's say if our phase is either ready for an instruction, which we'll probably rename, um, or it has updated. Well, I guess moved. No, sorry. We're talking about moves and updates. I was trying to I still have the three concepts in my head. I was trying to simplify this to two. Um, yeah, it's basically just ready and move. So we can move, or uh, we are ready to like accept instructions. So anytime we accept an instruction, we still are like ready to move, I suppose. Yeah. And has updated. I'm just gonna rename that. So this means that we have moved, right? Yeah. So we'll rename that symbol to has. Oh, it can't be renamed, but it's only used twice. Sorry for the diversion here. Um, it's something we can always jump back to and improve later. So it can move if it's either ready or updated. I think we'll just say if it's ready. So basically just is ready. We don't need that. But if you want to check with two different types, we could just check that P is a subset of the union of those types. So we can check that's one type or the other. If you don't have stages, then you'll have trouble making it run multiple instructions per clock. Yeah, like multiple at the same time, you mean? Well, it turned out like just the way that architecture worked, you could run everything in just two ticks. I'd have to pull up the files to remember what exactly happened there. Um, but maybe I will. It's kind of like FPGA season now. All right. And I'm glad you're liking exploring a type level approach to this. Let's see, recommendations. Joe Barnes gave a really fun talk about this sometimes. So this is still in Scala 2, and he gave a talk about doing a bunch of type level math in the Scala 2 type system. In Scala 3, that's actually easier. They just added, they just straight up give you numbers, like number literal types, right? So you can just add numbers. You don't have to do all this hack to make a number system inside of your type system. Okay, so VM state goes to updated. There is no updated. We're just talking about moved. So when we progress, we go to moved. These are the only things that move us to moved. And this keyboard lag is kind of killing me. I think, well, we're not running SBT. Let's just exit from SBT, shut down. Okay, store. So we can store if we are ready to do stuff, and the end result is that we are still ready. I think we should just say updated. We'll just do three types. So we are ready for updates. We'll have already updated. Because trying to merge those all into just one is making it more confusing. Making it two phases is more confusing than actually just doing three. I thought it'd be simpler. Okay, so questions we can ask about our state. We can ask if we're ready. Um, we can ask if we can move. And I'm going to say that is true when we are either ready or updated. So as long as we haven't already moved, we can move. Has moved, sure. And I suppose we could say can fetch. Ready just means can fetch. So we can do a find and replace on that later. So I'm just going to rename this method to can fetch. I don't know if I can. I don't know why that can't be renamed. It's probably because we can't currently compile, so I'll wait for that refactor until our code is compiling, and then we can rename things. Okay, VM state goes to updated. Great. When we push or when we pop, we also send our VM state to updated. And is this and we push or pop when we are currently ready. Ready to update, that is. And in this case here, we don't need to check is ready, because is ready checks if we are. Yeah, so this is going to be like can move. Can move. Right, and that's a check if we are ready or updated. Cool. So we have a can move restriction on progress and jump. We have a ready restriction on store, push, pop. We want that same restriction on, not on read, but on write. So using, sorry, what restriction is ready? Yeah, is ready or phase. And it returns VM state that has been updated. Alrighty. Now let's check that this all compiles. Here, you have a case. We cannot prove that P is ready. So we are requiring that we only progress when we are ready. I don't think that's what we wanted. So can move means what? Okay, can move means that we are ready or updated. What you're seeing there, by the way, this syntax, that's a type lambda. So you can read it kind of like a value level lambda, but the symbols are just a little bit different. Right, so P is a subtype of phase. So like it's like P of kind, well, not of kind, but of type phase goes to a function that takes P to like evidence that P is a subtype of the union of those two other types. So nothing we really need to understand, but in case you're curious what's going on here, that's called a type lambda. Okay, so progress requires that we can move, sure. Wait, is a function actually coming from store? So store needs is ready, and it gives us updated, right? So this is updated at this point, and we cannot prove that P equals Synacor.ready. I don't think we need to prove that it equals. I think just subtype is fine, because that's what we're getting. We're getting evidence that's a subtype. We'll move all these back to subtype. Okay. What's next? Okay, so this, we sort of need to be able to cast into ready. So we'll have an unsafe method here, def unsafe set ready. We're only calling this in certain like API-ish functions. And this returns a VM state that is ready. And we'll just do a cast. So this dot as instance of VM state that is ready. Okay. Unsafe set ready. Cool. I like making unsafe functions long names. That way they're not convenient and people don't reach for them. And, we'll make it private. We'll just do more signaling here. We're not supposed to do that. Okay, we cannot prove that a state is ready. What state here? So after we store, we're still on the same one. So store, we don't need to prove that it's ready though. Oh, wait, we need to prove that it's ready for store. I see. So what is this S? Oh, hold on. This S came from a pop. So we already popped and it went to update. Um, so we need a way to update again. I think I'll make that another library-ish function. Them boys, welcome, welcome. Yes, I'm still here. And yeah, I've gone full edgy matrix to go with the Synacor theme. At an old job, we once had a variable that, due to performance reason, had to be global. It was named something like "Do not use this. If you see this, fail the code review immediately." Okay, yeah, that's great. Um, let's keep chatting for a sec. I'm just gonna restart VS Code, kill all Java. I think I might have still been running an emulation from yesterday or something. And if you give me just a second, I'm gonna try and connect Twitch chat so I can see and hear your messages as they come in and drop some cognitive load here. Um, I see what's happened. So after our raid yesterday, it started tracking Liquid Cake's chat. That's the wrong chat. Okay, I have a way to track you for now, but you're still not showing up on screen. Okay, edit URL. There we go. All right. Thank you for your patience while I fix this. I think it should be good now. So if we give that a quick test. No, I don't think it's passing. Wait, did it pass? Yeah, okay, great. It did pass. Great, great. Well, now we can get back to it. 1 second here. Ah, there we are. Okay, I can finally keep track of you. Um, so where were we? We were fixing some type errors here. Right. We realize that we have a place where we can update and then we can update again. So I'll just add a method that lets us do that by setting us back to ready. So def update again. So we're going to get a function that takes a ready state, or that takes a, yeah, we're going to get a function that requires a ready state and goes to an updated state. And we're going to apply that on this function that is in, or on, sorry, on this state, on our current state. So our current state is ready. So using, or no. Our current state is can move, or basically, let's say using p is equal to updated. So we're currently updated, and this whole thing will return state that is updated. And then we just apply f to this, that unsafe set ready. Okay. I think that does the job. Now we can go back to that. Where was that error? I think it was in pop. Okay, so we pop, and that updates our state because it has been, let me see. Oh, it doesn't have a type anymore. But basically we want s.update again with a function, and that function will be, we just call .store, we just call this stuff on it. So update again would store a in W. And that should fix this type error here. Great. Great. Okay, well now it's explicit that we're updating again. It's a hoop to jump through, but at least we're explicit about our state. Now this dot pop cannot prove that this is ready. So we pop when we are ready. That makes sense. And then we say that we're updated. But we have evidence that we're ready to start. Right? So we are only in this function if you've already proven that P is ready. Not found type P, but type P is our type parameter. So VM state for this. Hold on, let me look what I'm doing. It feels like we have a syntax error somewhere actually, because it should be catching that P. All right. Now, in this case, we cannot prove that P is moved. So we're storing a value, and we cannot prove that P has been moved because it hasn't been moved. So this is actually a bug. So we need to regress before we go no output. Right. Regress. And it's not like we needed all this to find that bug, but this is like a test that you write once, and it applies for all future code that you're writing as you're writing it, instead of like write the code and then run a test, or like write a new test for that new code or something. So like it's not necessary. It's like a little bit gratuitous, but I think it's fun to think about. And you can get so much more complicated with it. And like the internals of the library sometimes use this to a great degree. You can even customize like what kind of error messages you get when you can't find them. So like you guide the user along with how they're supposed to use the library. Okay, anything else? Oh yeah, here we go. Okay. So that was a that was a longer diversion than I thought. But we can go back to our list. What we're actually going to do today is implement the main method, or the in opcode. But before we do that, we did fix a couple bugs. So let's check if our self-test is running any differently. Delete the failing test. Yeah. Oh, Alex, how are you doing? Yes, it is working. I can see you. Oh, wait. It's sort of working. So we did get a run yesterday. We were able to read, to output the welcome message of Synacor. WFM Macaw RMEM looks to have the A and B arguments the wrong way around. Really? I mean, they are typed, so I'm not sure. So store, um, from the register, the value of, and then some value. So store from B. Let's check the spec there. RMEM. Okay, read the memory at address B. So B is the address. Oh, okay, yeah, you are absolutely right. So B.address, read the memory of that. Let's get a run main going. And then store it to A. Oh, actually, I should have updated this before running that. Good catch. Good catch. Okay, and we do have a type error here. So type argument P does not conform to upper bound phase in our VM state. So type tick. I'm not catching this earlier. Yeah, the type parameter P, it needs to be a subtype of phase, right? So we say, oh, let's just put that afterwards here. So we have a phase. P is a subtype of phase. It needs to be a subtype of phase if we're using it as a parameter in the VM phase. Stupid Gladiator, welcome back. We are totally Matrix style. We're going hardcore Synacor. All right, so now we're running it. We're not running it because we are still getting compiler errors. Oh, okay, our main function. this needs to have an initial state. So when we start this, we need to just assign it a state when we construct it, and we'll just say that it is ready. Because every step function will take us from ready to ready. Okay, let's run that again. Running our compile, and is it possible for tick to be more restrictive? Yeah, there are many ways we could restrict it. Actually, I want to talk about tick a little bit because tick is actually secretly something else. And I want to at least explain what that is and leave it out in comments. But yeah, in what way are you hoping for, to restrict tick? Or were you just thinking about adding this type here? So tick here is secretly, this whole bit is a state monad. So you could actually implement this. Our tick ideally is just state of our state monad takes two parameters. There's that. Or it's state of a character and VM state. No, it is option character. And then this you could actually just implement as a state T as a state transformer of like option. So a state transformer has like some higher kind of type like an option, and it merges it with that action. So then in this case, the ticks would be, this wouldn't be a tick, but every output tick rather than clock tick. So option character and VM state. So there are tools for working with this shape of type we have already, and those are what those are called. So I'll just leave that commented for now. But it is in the to-do wish list and something we could explore later. You expect tick phase to be either ready or has moved. Well, in this case, tick is just, yeah, you're right. A tick would always ever be ready or has moved, wouldn't it? Well, actually, no, it would always be ready, wouldn't it? We never use a tick of any other type. So you're absolutely right. So I'm going to simplify that. We're going to remove the type parameter. And we can say that P is ready. And everywhere where we are passing a type parameter, so tick. And has moved, I think, does just mean, or no. We require it to be has moved when we're about to like return a tick, like wrap things up and put in a tick. So yeah, good catch there. I mean, it's kind of nice that trying to make things more restrictive like this tells us more about our program. So we know whenever we're ticking, it's in a ready state, and that's like a nice thing to, like, you know it, but once you formalize it and write into type, then you really know it, right? And then like your type system kind of teaches you as much as you're teaching it, right? Okay, so executing self-test, and oh, we had an exception fail. So great. We have our first bug to debug. This is in U15 from int, address from int. Oh wait, address from int, that's probably precisely the thing you were telling me about the BFM macaw, the switched arguments on the A and B. So we'll run Synacor again. And while that's going on, I think it's worth adding proper error messages here. So require, so when we're doing a word from int, it needs to be U15. So we can say n dot to hex string. Yeah, is not a valid U15 number. Okay, we'll just say, or no, U16. Unsigned. And I need a format string for this. I want to do like pad it to groups of 4. We can think about that later. I don't use format strings enough. Unsigned 16-bit integer. Great. And then we'll just have similar error messages for everything else. And I think we had the same thing fail because we called .address. So let's at least add the same kind of error messages. So from int to word, and U15 from int to U15 is not a valid 15-bit integer. Or you know what? This is not a valid 16-bit word, rather, because we're not using those as numbers. 16-bit word, unsigned 15-bit integers. And from int, like this would be like a valid index. And then we can follow that stack trace and find exactly where that error is. I'm gonna swap these two around. Oh, that is, it was cute the first time we had this slow message typing out, but now it's actually getting in our way. So let's go back to our main and let's make that sleep shorter, like 20, 4 times as fast. Seems reasonable. So 8000, so 1 followed by 15 zeros is not a valid 15-bit integer. And that's happening in our VM state. Dot step, where inside step? Right away, basically, right? I was trying to turn it into an address. Okay. So we'll look at that. I'm just gonna use the bathroom real quick. I'll be right back. Hello, I'm back. Thank you, thank you. Um, I was asking about or talking about hobbies here. So, do I have any other hobbies? Yeah, so plenty. I'm one of those people who sort of like collects hobbies, and will have like a hobby of the season or something, and be really into that for a while. Um, but my big hobby that's lasted for like much of the last decade has been dance. So I'm a big social dancer. So I do like West Coast swing and fusion and blues and Lindy Hop and waltz, things like that. Social partner dances. Um, I've been into baking bread lately, so I baked some bread. I was really into twisty puzzles for a while. I usually have one lying around, but there's not one within reach. Um, and this year I got really into poker. I was having a lot of fun with that. I even earned a nickname at the local poker games, like within within 2 weeks of playing there. So that's fun. But let's get back into this. All numbers are unsigned integers. All math is modulo. Yes. Wait. Plus 15? There's a plus 15 bit. Let me double check the spec. Because I kind of thought we already had restrictions according to the spec. So all numbers, all math is modulo. Oh, no, that's right. So this here, let's just verify this real quick. This here, I'm pretty sure is just 0xf or 7fff, or rather 8000, I think. So I think we already encoded that in 32768. Yeah. So I don't think that's the issue. No, that was an example. Oh, right, yeah. So adding 15. Okay, yeah. And then we're basically implementing that by enough. Baking helps keep me warm during the winter. Fair. Someone else was talking about baking here the other day. Sent like an easy bread recipe. Um, but then back to our stack trace, we have, let me get out of the way here. Um, that is not a valid unsigned 15-bit integer, and that is true, right? Because that is a 16th bit. So that's not an issue with the spec, but I'm more curious, how did we get there? I think it might help to get a list of instructions that have been running, get a log of instructions. So maybe we just print every time we go into the step, we print what the instruction we're about to run is. And then this message here won't come out as nicely. Or I guess it'll come out at the end after well, yeah, it'll probably get chopped up. I am inside the matrix, yes. Um, yeah, I don't have any other reason why. Can we get the exact line where that happened? Package.scala, vmstate.scala 130. Oh, it's inside step. So it's not like right at the beginning of step. Oh, when we're jumping. So next instruction and jump. Next instruction is an address. Okay, so it's one of these two. What I'm going to do is just put these on separate lines. The push and the jump. That way, when the stack trace gives me a line number, I know exactly which one it is. It's kind of silly, but hmm. Facing the VM instructions is very useful. Yeah, I imagine. Use a separate file so that standard out is not polluted. Or, I mean, so like this is immutable, right? What I could do is just kind of zip each function or like zip each state with um, the step that produced it, right? And then I don't know. I can play with it in the worksheet or something and just look up and down through that state. Keep the whole thing as data. Um, so the specific line it fails on is 132. So when we jump to a.address, great. So a is not an address in this case. And a is defined as the word at program counter 1. Okay, so that's weird. We have a call instruction, and the first parameter after it is not a valid address. I wouldn't know what to do about that. Unless, right? Like, what's the value of call? Call is just like 17 or something like that, right? We could coincidentally have tried to run random memory as a. If we tried to run random memory as an opcode, it's very unlikely that it would just even be valid. So we probably wouldn't end up right here. That'd be a really insidious bug. But why would the next thing, we push the next instruction and then we jump. Let me just double check the spec there. Spec. I don't want to have to like and dig into the bytecode just yet. So call, write the address of the next instruction to the stack, and then jump to A. So we're calling the function that's at A. And before we do that, we write the address of the next instructions that we can continue once we've finished our call stack for the function and returned, right? That makes perfect sense. So we're saving that next instruction for later. Oh, wait. A could be a register. You're right. You're absolutely right. There'll be a macaw. It's trying to register. Okay. So we've done this for values. A dot address. This is so we've done basically this for values. We still kind of have to deref as an address. Okay, I suppose we could deref in general to a U15. A, it was just the first register. So we already have a deref. That gets us a literal. An extension on Word uses that dereferencing. So value gets us a value. I think this probably is happening in a lot more places. So basically, every time we do address, right, we can jump. Anytime we convert to address. So I'm going to make an analog to this value. I'm just going to call it address, and it's going to return an ADR. And if it's U15, then we're going to dereference it. Except we're going to dereference it differently. So dereference takes it to a lit. I don't think there's any point in just returning the word. So we'll just get rid of deref. We're gonna have registers, w.register, and then .lit. And then down below here, we're gonna have registers, w.register, and then .adr. Cool. And I'm gonna use a hack for this refactor. I'm just gonna rename ADR here to address, or I'm gonna refactor rename it so it just changes everything. So all its call sites are changed. And then I'm gonna change it back to ADR without refactoring everything else. And now this extension method provides the definition of address. Okay. That whole refactor is probably overzealous, but we'll see. Compiler will guide us here. Actually, everywhere you use ADR, it's fine to use address, right? I mean, dereferencing when you don't really need to is going to be okay, I suppose. Jumping, how about here? Here we might, nope, we're not even casting that to an address, we're just transforming from another address. Okay, cool. Let's give that a run. Isn't the opposite true? If it fits U15, then literal, else register. Oh, let me double check that. Fits U15. Or no, we wanted that in here. Fits U15. If it fits U15, then we get it from, oh, you are right. Yeah, literal. And fits U15, let me just double check that so the function's named wrong or implemented backwards, which means it wasn't a bug just because, but you're right, that is confusing. So if the first bit is set, that's what this is checking, right? The leftmost bit doesn't change anything. No. Yeah, if you zero out the 15 bits on the right, then does the first bit remain set? So this is basically a check that it is a register or that it doesn't fit U15. So I'm going to change that to not equals, and I'm going to go to the call sites, and we'll update that. So if it fits U15, then it's a literal, else that. Okay. Then we could actually just do the .adr call at the end. And either, so like we could sort of have like a maybe dereference function. They're both doing the same thing. I don't think that's a refactor we need to do right at this moment. But it's just the thing at the end. Yeah, let's just make that our deref function and reuse it. And it's not really an appropriate name for it anymore, but I think it's the thought that counts. So deref a register to a word. Yeah, it still pairs nicely with store. Store deref gets us a word, NW else registers And in that case, it's actually a U15, but we're not giving it that type because we're just going to use it right here. So dref w dot lit. And we'll do the same thing here. So dref w dot adr. Okay. So now we are dereferencing addresses. Let's give Synacor another run. Oh, we have type errors here. Compile errors still. So what did we break? Not found W. So we're dereferencing a word to a register, or like to the value of inside a register. Okay. Deref is the wrong name. You would dereference a register, not a word. But I'm just doing this for the shape of the code. Okay, anything else? Great. Oh, hey. This is something. This is actually something. What? Are these? What are these characters? So they look like kanji, but is that just like a default character when my terminal can't print it? I think my terminal can print emojis. Hmm. Okay, let's copy that into here. Let's go to the, I don't know, my playground. And no. Okay, so looks like I'm trying to print things that aren't being dereferenced correctly. Yeah, I suppose so. Um, I don't think it's like an encoding issue. I feel like this is more a bug in my program because I think I'm pretty sure SBT handles emojis and does that sometimes. Right? And I can like echo, I don't know. Oops. I mean, it's right there, right? So it's not an issue with my terminal. Wait, what's going on? Maybe it can't handle them. Yeah. Looks like I'm trying to print the literal instead of reading the A. Yeah. Okay. Yeah, I'm printing the register reference. So let's take a look at that. Out or out. Here we go. This thing progress to output A. Oh, A. We didn't do anything with A. Interestingly, why did output not fail that? Output word. Wait, is that a register? So it is a register, right? Not an address. It makes sense for it to be a register. So let's dereference that. Like if it's a register, like, it doesn't hurt to add this either way. Because we don't know that it's necessarily a register, right? Write the character represent by ASCII code A to the terminal. Yeah, it only tries to print plain ASCII. It'll never try to print characters like that. Okay. Um, but A is not literal. So I don't know if A is never a literal. Like the way it reads to me is that it's always a literal. But I guess it doesn't matter because this is either going to dereference it if it is a register or just pass it along as the same literal. Uh, in which case, yeah, let's just run that. So, ooh, foothills. You find yourself standing. Um, okay, so we've stalled out. We've stalled out, which by this point we know what that usually means. And that usually means that we're not progressing. Except I kind of thought that this was something we fixed with our type system. Oh, okay, we're still doing this kind of stuff. We can't be doing this dot copy for one. You don't want any copies anywhere. So I'm going to change this. Jump to b dot address. Jump to b dot address. We don't want to be messing with the implementation details in here. If I had like a type safe way to abandon copy, I would just do that. Okay, yeah, copy should only be used by the utility methods. Cool. But I don't think that was our issue, right? It would be that a program did not progress. And it looks like everything progresses or jumps, right? Jump or progress, jump up or progress. Here we jump, we progress. So we know it's not waiting for, well, hold on. Input would fail here. So input would halt it. And it's not halted, it's still running. I'm just going to change my main function here so that once it's done with everything, we say, oh yeah, we already have that actually. So Synacor halted. It does not say Synacor halted, so we know we actually haven't hit an input yet. That's a fascinating place for it to stall. You find yourself standing. uh, where is the standing desk when you need it? So I need to start outputting my instructions that I'm printing. Like it could be at the point it froze, I'm pretty sure it's just in the loop printing characters, not doing anything different from the previous few opcodes. Okay, that is interesting then. Right, if we were just printing characters repeatedly, we're repeatedly going to out and progressing and outputting the character at A. What does this look like? When you're printing all these strings, it's like outward, 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 outward. We could look for chunks of that. Like we could search the binary. I kind of want to disassemble the binary, or at least see, all the opcodes, see where all the opcodes are, and then like the values of the things following the opcodes. And whether they are like register references. We'll probably have to do that at some point. But I don't think we have to do it now to debug this one. So if it's not when we're calling out, or pretty sure we're not calling for input yet. If a dot value is not equal to 0.2lit, sure. I should just have a boolean 2lit. We don't need to make that like expression right now, but boolean 2lit. That might make using it a little bit easier. We haven't hit this. Okay, yeah, we're gonna have to print some sort of. Let's just start really small and print the program counter on every step. Yeah, we'll print the program counter on every step. Tab. Wait. Oh, I don't want to do it that way. We'll do it here inside of our code. I guess I got indent the whole thing. Fine. And we'll do a print line. To hex string. Oh. We need that as a method on address. So we'll add that in real quick. Wrong package. So we have numbers, our numbers package. So here, we can add this. We have a hex, and that's just going to give us the string for this. And we'll do w.to hex string. And I'd like to do that with some formatting. If anyone knows %0 pad with 0 to 4, I'm going to do that. Okay. So we're going to print line the pc.hex. And it's not going to make our output pretty, but we'll at least see if we are in a loop if the program counter is not moving. Wait, what? Huh. The rest of the output showed up. That's interesting. It's like SBT. So we have a message. Okay, well, we'll try that again. Flushing? What do you mean by flushing? A buffering flushing issue? Oh, like my iterator? So in my main, how am I doing this? I'm doing this, like it could be the flatten, making. So this is just for each on an iterator, which is a while loop. Iterator has next. And the way this iterator is created, let me unfold. I don't want to jump into that too much. We'll just try it again and cross our fingers. Like my output pipe instead? Right, in my terminal, you mean? Okay, that makes sense. Yeah. Like maybe I accidentally pushed Control Z or something like that. Oh, I mean, we don't need that anymore. But also that wasn't printing the way I was expecting it to print. I think I need to have an F in front of it or something like that. If anyone knows the format string, I'd appreciate that. But for now, let's just see what the actual message says. We've been skirting around this for so long. We should actually just read what the message says, right? Okay, Synacor or run main, Synacor.main. But before we do that, we're going to take our print line and get rid of it. I might need an explicit call to whatever the standard out.flush is. Okay, maybe. Good to know. Thank you. Print is sending things to something that's waiting for some condition. Okay. All tests pass. The self-test completion code, we can run that. You find yourself standing at the base of an enormous mountain. At its base to the this is Zork. We're playing a text adventure. At the base to its north there, I feel like I'm missing some of the text. Like it went off screen and we're not wrapping. Things of interest here. There's a tablet. There are two exits, a doorway into the south. And then the VM halts because we asked for input. Okay. I'm gonna run that actually above the terminal here. Run main or dot Scala. So this should be wide enough. Or no, Synacor dot main. While we think about our input. Yeah, there's something weird about my output buffering. Uh, it's not the kind of thing I want to debug. Maybe I'll look at that off stream later because I want to do the interesting stuff here. So iterator.unfold. So when you see the spec or input, read a character from the terminal and write its ASCII code to A. Right, so this can be like a virtual terminal. It can be assumed that once input starts, it will continue until a new line is encountered. This means you can safely read whole lines from the keyboard and trust that they will be fully read. So hmm, we're doing a lot of print, and then we have a nearby sign reads "Keep out." Definitely no treasure with. Oh no. I need word wrapping. What I could do is every time I hit like a double space, every time I hit a double space, I just insert a new line. We can implement word wrapping ourselves here. We'll do a hack. Well, so if character is if character is a new line, we do have to reset. So if character equals new line, then we'll do a variable for columns. Var col equals 0. Then col gets set back to 0. Else, then we're incrementing column. Col plus equals 1. Well, we also have a case where we need to check if col equals 80. So if column equals 80, then we're just going to print a new line ourselves. Print line. Otherwise, oh, I don't think this doesn't even need to be an else, right? Just if column. Yeah, that works. So if it's new line set back to 0, if it's 80, we print line. Otherwise, we just print the character, or regardless, we just print the character and sleep. Okay, we could at least read this. And I should have like a more graceful way to drop out of these. Oh, that didn't do anything. So we're incrementing the columns every time. Oh, I suppose we're just going to regardless call plus equals. There might be an off by 1 here, but we don't care. Okay. You find yourself standing at the base of an enormous mountain. At its base to the north, there is a massive doorway. A sign nearby reads, "Keep out. Definitely no treasure within." Okay, there we go. Things of interest here. There's a tablet. There are 2 exits. And then what do you do? Cool. We can read that. Um, so we can provide like we can provide a whole string of input. So our state needs to have like a with input function. Like regardless of like where our input comes from, the terminal or from source code. It is suspicious that only wrapped once, isn't it? Um, it worked for now. If column equals A, then print line, and then I need to set column back to 0. Oh, no, column goes back to 0. Yeah, that makes sense. Okay. You can safely read whole lines from the keyboard and trust that they will be fully read. So we step, and then we get into a VM that is looking for input. What does that look like here? So we read the in instruction. We call step with a parameter. Like this could be an input stream. This could take an input stream as a parameter. But I don't love that. Like certainly from an external API standpoint, like you do need input. Okay, so we still need to be able to get the ASCII code of a character. Um, and then I suppose once we hit in, then from the outside we call step with our next character input. So they're might not be input yet. No, I don't like that. This is a reader. Okay, so what we'll need to know, let's remove this for a second. We'll at least need to know from the outside if we are, if the current thing is an input. So if it's waiting for an input, I suppose we could give it a function to call for input. So in could be a character. I borrow check, by the way. Welcome. Yes. Yes, we are writing in Scala, which does not have a borrow checker. But sometimes I feel like you could probably write a borrow checker in a type system. I don't know. Probably not. There is a Scala native, so maybe someone's had that thought. Um, right, let's just pass along a function that gives us our input, and that function's gonna be side effecting, and yeah, we'll just then defer like read line. So step, we could make it a parameter of the VM itself. Now let's make it a step. So input is a function to string. And now we just take input, yada yada. And this is just going to be one character at a time, right? So we're going to print the current character. We'll still have like a whole kind of stack of characters to print. Because I want to do the whole string all at once, ending with a new line. I guess I could just progress several times within a tick and break our rule. So we could take input, this gives us a string, dot fold left. So we basically start with our current state. So with this, and we will repeatedly store and progress, or no, read. So in case um, we have a state and we have a character. And we need to turn that character into ASCII. Char dot well, it suffice to do a to int. And then we could do as the word. So word dot from int character dot to int. So there's the ASCII. So val ASCII. Not sure if that's correct. I think so. It's going to be like like the character is Unicode and ASCII is a subset of Unicode. And then we write that to A. So we're going to take our state dot store and A dot register. We'll continue until a new line is encountered. Well, hold on. That doesn't make sense to keep putting it in the register, though. I think it has to execute other instructions afterwards, right? A dot store, A dot register, and ASCII. And store works with an arbitrary word, yeah. It works with a literal. So we'll do dot lit here. Okay, so now that works. There's a lot of typing version going on here, but we don't have the proper methods yet. Okay, and we're folding this into a whole new state. So after we store, we progress. And then there's no output. But then we're folding left. There's a really nice way to do this if we were using like the full type level stack. Right, that just means it's not going to call in once and then go off and do some output or something. It's still in the loop calling in. Help languages have easy line buffered input, but difficult character buffered input. It's not going to go off and do some output or something, but it can still do other things in between characters. That makes sense. So we can't just do a fold left. Then we need some sort of buffered input. So like the input can just be part of the state. And then we pass that along, right? Like we have an input stack-ish thing. And then when we call in and that stack is empty, then we interrupt the world to do a read line. Which I don't I don't like what that does for like the rest of my program because that might come at like a weird unexpected time. And it's not like a repeatable thing. I want to do this in an IO, is what I want to do. Mm, yeah, I want to do it in an IO. I think as a hack, it should work to just stop the world and do a readline call. Okay. Well, I'm gonna grab some water and I can mull it over while that's happening. Alrighty. Hmm. Okay, so we'll do a stack of characters as our input, or a linked list of characters, and make that be part of our state. And occasionally we'll ask for the full thing, and we won't do anything else until we get a full line of input, and then that stack of input characters can just be consumed on each tick. Okay, we have an input that's a list of characters, and we'll have a next character. So we don't have this input function, not for now at least. We might bring that back again. So input, we'll just match. So character, um, if it's nil, then we go into like a new state. Where we get, we populate our input from readline. So if there is a character and in the next bit, then we take that character and we turn it into ASCII. So we're from it lit ASCII equals that for the character. And then we're gonna store it. We store, we progress, and we do no output. That seems reasonable. Oh, right. We also update our input. So we're gonna let's do a copy. Input equals rest. Name this to rest. I'm gonna name this C and C's. Rename that C, character, and C's. Okay. And then otherwise, we do val next line equals system dot read line. Let's open up a REPL. I want to test it out. Okay, so can we actually just call read line? Read, no, system dot in dot read line. Read all bytes. I want a full read line. System dot in dot read. Just read. See what that does. But that returned an int. Oh, that reads a single character. IO, that's standard in that read line. Oh, yes, standard in that read line. Thank you, thank you. IO, that's standard. Read line. Okay, but we've got it. I appreciate that. IO dot standard in. Right, we're using standard in rather than standard out. Read line. And we're going to take our state and we're going to copy input equals next line dot to list. So there's a list of characters. And then from there, we do kind of the same thing we did here, right? So I think this, like part of this can be a helper function. So it could be like consume input. And in this case, we're just first loading the input. Otherwise, exactly the same. For now, just to get this working, because I do want to like interact with this. Let's take let's give ourselves a function here. I want to keep it all in this closed scope while we're figuring out what we actually want. So def consume. So this is gonna progress the input. So this is basically like pop, but on the list. So consume character def pop. Read whole line buffered, please. Okay, okay. I think I can just do like dot buffered on any stream, right? I am not a systems person. Okay, we'll figure that out. But first, let's get a basic thing working. So to consume character, we'll do much what we did here when we were popping. So using is ready, I suppose, yeah. Which means I think when we load that one, we'll also just go back into the is ready or back into the state, yeah. It was ready state so we can consume again. And now we would do this with the characters, so input.head option. And now we're returning the word and VM stack updated. So now when we're using this, well, I think we want also a function for this bit. So store ASCII. Well, I don't know. Eyebrow check, by the way, is an ocameler. So we come out with a word. We're gonna write that to a register. I actually don't like. I don't like doing it this way for this one. Okay, we'll do it. This consume character. So match case. That's just like when we popped earlier. Pop. Except in this case, none is not an exception. So consume character is just doing the same thing but updating the state. No, I'm not sure. I like that. I just want to get there. So we're gonna comment this out. Will be slightly hacky. We don't need this bit here anymore. So we get our line, we convert it in here, and then I guess we recurse, and then we step. We just step again. Huh. Yeah, that is right. We just step again. Because now we fixed that. We fixed that there's no input, and we step again. And step does a whole proper output. Okay. Well, I mean, that should type check, right? What's this S? In input.match. Oh, this is a this.store. Okay, we copy with the input change and then we progress and then no output. Cool. I'm still torn by that because I want to make it much nicer, but I have to like stop and really think. I think that's the kind of thing that's maybe not as fun to watch. Hmm. Step is not a member of any. Oh, what happened here? VM state not ready. Oh, yep, we need to actually VM state. Let's just default that parameter to nil. So input, which is a list of characters, we're going to default that to empty. So that should be able to compile. Okay. What do you do? um, look at tablet. Hey, I pushed enter. Did we forget to progress? We're not going yet. I'm stalling this out so much. Uh, so next line, standard out read line. Read a full line from the default input, returns null if the end of the input stream has been reached. The string read from the terminal or null if the end of the stream was reached. All right, so read line. Okay. And I guess since it is just standard in, we could start typing stuff in before um before this even runs, right? Um I could just run it with like standard in already piped in. You need to append an explicit new line. Oh, right. Yes, you are right. Thank you for that. I thought that in my head and then I forgot about it. So we're gonna do plus no, we'll do the character. Or you know what you can do? Let's turn that into a list and we're gonna content whole thing onto a list of just that character because now we have a list of characters. Um, mm, could be nicer, but we have that, it works. Okay, here we go. Here we go. Let's play the game. Well, what happened now? Is it stalling because there's another SBT thread still running? Oh, right. I forgot about that. Okay, kill that. Um, let's make this bigger. Okay, let's start that again. Foothills. You find yourself standing at the base of an enormous mountain. At its base to the north, there is a massive doorway. A sign nearby reads, "Keep out. Definitely no treasure within." Things of interest here. A tablet. There are two exits, doorway or south. Um, let's look at tablet. Oh wait, is this the one that we forgot to rerun? No, we just ran this here. Run main, synacor.main. So it should be considering my new line character there, right? Or wait, does that count as input? It should be sitting and reading a line. I mean, part of the problem I feel like is that we are calling read line from inside the run of an iterator. Um, you know what? We could preload this. Let's preload. Okay, this is a little bit hacky, but we're gonna preload our first input line because I just want to see what happens next. So we have main, we have memory equals memory, and we have input equals look tablet or inspect. Maybe inspect will work. Inspect tablet dot to list. Inspect tablet new line dot to list. Right. Okay. I should really speed that up. I don't understand. Try help for instructions. Oh, okay. Right. Let's start with help. Slowly. Help. And let's see. Let's speed this up. Let's double the speed. So you may look to examine the room, or you may look subject. Oh, look tablet would have been it. You may go exit to travel in that direction, such as go west, or you may merely exit. Okay, so you can look, you can just look, you can look subject, you can go, and you can check inventory. Inventory might be a first good thing. Inventory, take. Okay. And help. Can I run that again? Right, that's what it looks like when it's stuck in that loop there. But oh, you know what? Thing it's an infinite loop. It's recursing. Let's change this first thing to inventory, or you know what? Look tablet, and then let's have that run. And while that's running, I know what the issue is here. So we recurse. Wait, so this pauses the world, right? When we read line. This is not asynchronous. Never mind. I thought for a second that that might be asynchronous, and then we just keep calling step repeatedly because we don't have anything yet. I like it better when it's just that. This that copy. So we load it up, and then we try the step again. If it turns out it's empty. That seems fine, but let's add a message here so that we know what's happening. Wait, and read line can take a message string, right? Here, read line. Yeah. Okay. So we'll throw in that message, and then I don't know. So we copy the val s equals that. So we have a new state. And then print line about to recur with state. And then we just print s. So tell us the current state, and then we we try to step again. Okay, that should be a little bit helpful. The tablet seems appropriate for use as a writing surface, but is unfortunately blank. Perhaps you should use it as a writing surface. Oh, okay. Yeah, use tablet. Open mailbox and take leaflet. Right. Um, I remember that. Link to Pearl. For sure. So let's try this again. Oh wait, was that inputs? That's that step. Cannot prove. Oh, for fuck's sake. Yeah, you don't like my hack, do ya? So step. Well, when you step, right, the phase that we're copying from, this copy can take. I think that should take a pipe parameter. So we're just gonna say ready. I'm just gonna say that that's a ready state. Okay. Use tablet. And man, I need to learn how input works. Um, read line. I need to like read some documentation, I guess, because I'm probably misunderstanding. I don't know who's worked with a lot of read line input. I don't feel like this is an uncommon foot gun. Input is a list of character. Okay. um, we are just gonna script all of our inputs in advance. So we can do this by having multiple lines. And this thing reacts to new lines, right? Yeah. Yeah, we can totally just do a multi-line string and then have that be a list of characters. And we'll never have to run into the empty case and do a read line. So first we look at the tablet. Well, first let's run help. Then we look at the tablet. Let's try using the tablet. And what else did we have? Let's look at inventory, INV, and then let's go our two exits. That's based in the north. There's a massive doorway. So doorway is north and south. Wait, a sign reads keep out. Definitely no treasure within. Do we do the doorway? Sure. I want to do the doorway. Um, so go doorway. And then we're gonna look. Okay, so we are scripted ahead. And yeah. Okay, so here's the help. You may merely look to examine a room you may look at a subject. You can go to an exit. Oh, wait. You can go to an exit. You can take an item. Oh, I should have taken the item before trying to use it, I suppose. Yeah, I think you have to take an item before you use it, maybe. The tablet seems appropriate for use as a writing surface, but is unfortunately blank. Perhaps you should use it as a writing surface. What do? You can't find that in your pack because we didn't take the tablet. Okay. So we look at the inventory, and my inventory is empty. North is a dark cave. It seems to be the mouth of a deep cave. As you peer north into the darkness, you think you hear echoes of bats deeper within. Well, I don't want to be eaten by a grue. Yeah, I don't think we go much more south there. So we look at the tablet, sure. We're gonna take the tablet, then we're gonna use the tablet. Inventory, why not? But let's go south instead and take a look there. And we're gonna double our speed once more. Foothills. As you leave, you feel the urge for adventure pulling you back in. There's one exit north. What do you do? Um, wait, why did this show up twice? What did I say I did? Go south. Oh, yeah, we looked. And all we can do is go back north. Okay, so we gotta go north and go north again. So that gets us into the cave. Once we're in a cave, maybe we take a oh, it's not necessary to look, is it? What happened last time we were at the cave? Yeah, there's nothing to take. So we go north again. Oh yeah, of course there are Easter eggs. um, a 100% run through will require a disassembler. Maybe a full-on decompiler. That's certainly some way to inspect the binary. Okay, edge of an enormous mountain. We go north. Oh, wait. Oh, no. Doorway. Okay, let's backtrack a bit. So there's no go south in this run through. Um, we look at tablet. We take the tablet. We use tablet. Oh, I don't know what that actually ended up doing. Um, we don't need to check our inventory, but we're gonna go doorway, and then we're gonna go north. You're confused by why the read line works in the REPL, but not in the actual program. Well, it's not working. Oh yeah, why? Yeah, I know. Um, I am confused too, and I think it has something to do with the fact that I'm mapping over an iterator, or I don't know why that would be. I mean, the iterator is just a while loop, right? People do reads and prints and while loops all the time. Ice Cold Witch, hello, welcome. So we went north. I should print what it's doing at each of those points. Um, and then, you know what? I think I have something for this proper tiling. Mm, yeah, I'm gonna tile it this way. And I'm just going to keep my code really small on the right so that we can keep track of what our movements were. Okay, is legible. Okay, we can drop help because that's not input we need. And we can just, we'll still look at the tablet, take the tablet. What happened when we used the tablet? We wrote, oh, hey, that's a code. Cool, we got to use that code. Let's do all of these. So there was another one. So some that, and what was the other one after the power on self-test? Here, self-test completion code. Whoops. Oh, we're missing the close paren. There we go. And just so they are in my history together. Okay, so that's already 3 codes. Nice. Um, yeah, I almost skipped over that one completely. As you peer north into the darkness, you think you hear the echoes of bats deeper within, so we go north further. The cave is somewhat narrow here, and the light from the doorway to the south is quite dim. There are 2 exits north and north. Let's go north once again. And I think we can skip the part where we take the tablet and look at the tablet. So we don't need to look at it, we don't need to take it or use it. We can just speed run. And you know what? Let's keep going north. It might only be 2 directions. Go north. Nope, it doesn't work. Don't lose or overlook any codes. Yes, yes, I'll check the codes. Right, let's pull that up. Actually, let's look at the MD5 sums. Here we go. So what did we have? We had 44 ending in 42, 44, 42, right? This is the very first one from the welcome message. This one's from the power on self-test 5B59. So 5FB59. Okay. And then this third one here going up 98 CCE, 98 CCE is also correct. Good, good. Dark cave. The cave acoustics dramatically change as you find yourself at a ledge above a large chasm. There's barely enough light here to notice a rope bridge leading out into the darkness. There are 2 exits, bridge and south. Okay, so after 3 north, we go bridge. Oh, I guess we preempted to go north, but can't actually do that, so go bridge. Yeah, I am going all full Matrix edgy today. I haven't got my vape. So the rope bridge creaks as you walk along it. You aren't sure how old it is, or whether it can even support your weight. There are 2 exits, continue or back. All right, I guess we kind of have to continue. You know, I'm not so sure about our current album, though. I'm gonna skip back. Okay, so we fall through the air because we try to continue. You try to grab the bridge, but it evades your grasp in the darkness. You're plummeting quickly downward into the chasm. There's one exit down. Well, if going down is the only way to stop falling, then why not? You wish you knew enough to help troubleshoot the standard in bug? Yeah. Like maybe it's not even hanging at standard in at all. Like maybe no, it hasn't halted. I don't know. It looks an awful like a lot like it's not progressing, doesn't it? Let me just take another look at that. What's gonna happen is I'm gonna wake up in the middle of the night and have ideas. Um, input next line. We do step. Wait, s dot. Wait. This dot copy. Ah, it's the same. It's the same symptom all the other times you forget to progress. We forgot to progress. S dot progress dot step. Oh no. Yeah. No. We don't need to progress because we're not reading the character yet. We're just stopping to do a read line. We haven't actually done anything. So we'd be ignoring input if we did that. So it really is S dot step. But the thing is, this print line here never even, this about to occur never even happens. So it really just is hanging on the read line. Um, yeah, that won't be fun to debug. I'll do that off stream and maybe tomorrow I can let you all know what it is. So we go down. You are standing in a large cavern full of bioluminescent moss. It must have broken your fall. The cavern extends to the east and west. At the west end, you think you see a passage leading out of the cavern. There are two exits, east and west. I'm gonna go east. I can print the instruction it's trying to execute, but it would do a lot of spam. So like I need to actually just save that into a file instead or something. But yeah, like a standard error. I should print to standard error rather. But we know exactly where it is because we do see the line run. Um, this input line gets called, right? This print line, or that shows up in the terminal. So there's input down here, and then this print line never shows up. So it's literally just waiting for input. And I don't know. Let's see. Like, what if we did maybe an SPT console and try a read line in there? But yeah, we go east. And then there's an empty lantern. So let's go look empty lantern. And then take empty lantern. I'll try to use it. Use empty lantern. Okay, let's try that. And then I suppose we go back west. And I'm gonna just go back west right away. Because we know go west and then we go west again. Okay, the rope bridge. Falling through the air, the moss cavern. So from the moss cavern, we go east, and then there is an empty lantern. And we look at it. The lantern seems to have quite a bit of wear, but appears otherwise functional. It is, however, sad that it is out of oil. So we take it. We aren't sure how to use it. Okay. And then we go back west. So we're back here, and then we go west some more. You're standing in a large cavern full of bioluminescent moss. The cavern extends to the east. There's a crevice in the rocks which opens into a passage. So let's check out that passage. Okay, you're in a crevice on the wall of the moss cavern. A dark passage leads further west. There's a ladder here which leads down into a smaller, moss-filled cavern below. There are 3 exits. Cavern, ladder, darkness. What do you do? Um, the dark passage leads further west. The passage is where we... Wait, is that... Yeah. So the passage is where... That's where we've been going. So we came from the east. Um, how do we go backwards? Cavern goes backwards, I suppose. There's a ladder here which leads down into a smaller moss-filled cavern below. Oh, no. I think ladder leads back because that was the moss-filled, the bioluminescent moss. Okay, so I don't think we want to do darkness yet. So let's go. Hold on, 2 of these seem like the same thing. So the ladder leads into the cavern, right? So 2 of these exits are just the same. Let's start with cavern and see if that just takes us backwards. And if that doesn't work, we'll try ladder. Do I have a mechanical keyboard? No, I do not. um, what I do have is one of these track point keyboards. If I were to get a mechanical keyboard, it would have to have a, a track point. I'm like dependent on that now because I don't want to take my hands off and use a mouse. I mean, here's one consideration. Let's say you're playing a game that has a lot of keyboard stuff, right? So, all my key bindings on the right, perfectly accessible because my index finger is how I use my mouse, right? It's basically a bomb half of a ThinkPad, totally. So we go into the moss cavern. Okay, so go cavern takes us backwards. Let's go ladder. Uh, okay, twisty passages. Oh, it's one of these. You're in a maze of twisty little passages, all dimly lit by more bioluminescent moss. There's a ladder leading up. So we have to make a map of this. Hmm. Twisty little passages. So let's pull up. So the start of the twisty little passages, and I think we'll draw this in green. So start is a maze of twisty, uh, yeah, we'll do capitalize. Twisty little passages. And then we'll try each of the directions. I mean, we could also let's just try the darkness and see what happens in there. But I get a feeling we'll just like be eaten by a grue or something. It's true. It is pitch black. You are likely to be eaten by grue. And then continue, we die. I knew it. Of course. I don't have a light. Without a source of light, you become hopelessly lost and are fumbling around in the darkness. There are two exits forward and backwards. Okay, we have to see this. Forward. Uh, you can't seem to find your way. However, you do think you hear low growling in the distance. So, what do when you run to a grue? Like, certainly don't investigate. So we had no choice but to run, yeah? The growling is getting louder. Did I mention there are grues down here? Hmm. How are we supposed to hide? Um, it's not like you can find a hiding spot, and we're dark already. Um, or like the grue's fine in the dark. So let's just wait for a death. Let's just wait for a death. The growling is getting louder. Did I mention there are grues down here? And you have been eaten by a grue. Synacor VM halted. Hey, we hit the end of the VM. Look at that. Okay. Um, that was fun, but what we actually want to do is not go passage. What was the other one? We'll keep this. So that's the grue death. Go west, go west. What's it? Go ladder? Yeah, game over. We're done. We finished Synacor. Um, wait. Use the empty ladder. We can't use the empty lantern. We don't need to look at the empty lantern. Just take it. Go east, go west, go west. Um, and then I guess go west again. And then passage. Go passage. Well, and then the cavern, right? No. Cavern should be backwards. So we're gonna go to ladder. Go ladder. Right, we came down from above. Okay, so twisty little passages. Let's start by going north. Go. Can we just say north? I'm not gonna risk it. So we're in a twisty maze of little passages. So the first one is maze of twisty little passages. Um, let me just erase that. So we have a maze of twisty little passages. And then we found a twisty maze of little passages. I'm going north. So twisty maze of little passages. Then there's north, south, west. Oh, there's no east. So I think that's worth noting. Um, so east is a dead end. So let's just go north some more. So now we're in a maze of twisty little passages with north, south, east. Wait, that doesn't seem. Maze of twisty little passages. Twisty maze of little passages. Maze of twisty little passages. And we can still go north, south, east. Oh no, there's no west now. Interesting. So when we go north further, it is once again a maze of twisty little passages. I don't think it's the same as the original because west is forbidden. Yeah, yeah, west is forbidden. I don't know if the arrows actually point back at themselves yet, but let's keep going north. Wait, I keep reading it wrong? Oh, hold up. Oh boy. You are in a maze of little twisty passages. Ah, okay. A maze of little twisty passages. Uh, you know what? I struggled with that the first time too. So, maze of little twisty passages. Little twisty passages. Cool. Okay, and then there's a ladder. You're in a maze of twisty little passages, and there are 5 exits. Yada yada. So that kind of gives me faith. Um, well, we'll just say MTLP for now, and then we can say that they're identical later. MTLP. And then this one can go in any direction. Okay, now let's go south from the first ladder and see if we get to MLTP. And I suppose I can skip the part where I take the lantern for now, just so that everything loads faster. And I guess I don't really need to have a thread.sleep. Okay, you're in a maze of little twisty passages. And yeah, that's MLTP. Exactly. MLTP. Okay, so it is a full loop. And I don't know how big to draw that loop. But let's start with that. Now, from the maze of twisty little passages, let's try going east. Wait, what? Stack trace suppressed. Rejected the job. Okay, SBTN shutdown. Oh, wait, the SBT server is disconnected. How did I kill it? Oh, is it just... Yeah, let me just try. IO.standard in.readline. Readline is not value. Oh, we've got to capitalize L. Yeah, yeah. Still works even in SBT console. I thought maybe the fact that I was running inside of SBT might make a difference. Is that Comac you see? No, no, that is that's Dvorak. When I started learning Dvorak, Comac wasn't even really much of a thing. Yeah, I've been doing it since I was a kid. I'm too old to have done Comac. Do you type in Comac? Um, you ever do type racer? I don't mind a quick type racer break. Um, oh, I don't know why the compilation would stall this way. I mean, we run compilations, and it was happening in like seconds. It's almost as if like incremental compilation failed and wanted to recompile everything. Even so, this isn't a big repo. So I don't know. I think this is a kill-all Java moment. Maybe I have some worksheet giving me trouble that I'm not aware of. This isn't my normal experience, like developing with Scala to have to do this. It only really happens when I'm messing around with worksheets. And right now I haven't really looked into it, so I'm kind of waving the magic. I'm in the superstitious stage, right before I actually understand what's going on. Yeah, well, while that's compiling then, since we're waiting, might as well. Let's do type racer. I'll drop a link in chat so that anyone can do that. Oh, look at my input lagging. Maybe it's like some sort of WSL thing. I don't know what is running. Oh, this SBT is still running in my what's going on in a terminal? It's still trying to cancel execution here. On that one? No? Kill all. I gotta do that before my stream dies. Ah, okay. And any worksheets that are on, I know, let's hold on. Let's actually open. Let's not actually open buffer. None of these are worksheets except play worksheet. So let's kill that. Oh, you know what? Into twisty little passages, I suppose I could like preemptively go east again and see if doing it 3 times gets us back to where we were. Oh, we're not repeatedly reloading. Okay, SBT. All right, we'll let that start up. And I'll sign in over another screen in case I leak a password or something. Alrighty. So here's the type racer link. I'm gonna let it run in the background. Is that you, the guest? It doesn't seem to have a text ready. Click on join race to begin. Oh, I have to join race. I see. All right. If I lose, I can just blame it on my computer lagging. Oh, there you are. There's Zuno. All right, here we go. 5 seconds. Appeared on Synacor when the green lights on. Circuit jump. Lost puddles gathering. Ha! The curves. Ah, that was really close. Well done, Zeno. And who else was in there? Yeah, well, that's too close. Next time I challenge you, I'll have been warmed up. Okay. What's happened here? We have SPT's loaded up just fine. I'm gonna try to run main. Maybe I should just like htop over here and sort by process. That was you in there. You just got out of bed. That's fair. That's fair. Okay. It's compiling. This is so weird. This isn't normal for that to compile that slowly. But now it's running. Hopefully we're back on something stable. Without a source of light, you have become hopelessly lost and are fumbling around in the darkness. Wait, what? Oh no, we ended up... So there's a groove somewhere in here. So there's a ladder up, and then we go east. You're in a maze like of a like little passage is all twisty. Oh, that's very different. Um, I'm gonna call that MALP dash T. That was not in my naming scheme. Okay, so the start is here. We want east, and we've got MALP. I guess this like convoluted sentence gives you a it's a sign you're about to be eaten by a guru. So we're fumbling around in the darkness, and probably we're gonna die. So let's go west instead, and let's try west 3 times in case that ends up getting us back. Synacor challenge is moving on to wumpus hunting. I'm not sorry. What's a wumpus? um. So when we go, so here's the one with the ladder, right? Then we go west. You're in a little maze of twisty passage. LMTP. LMTP. And then when we go again, oh, we can't go west again. So from there, it's north or south. So west is blocked off. That's north or south. So let's go west and then north. And we can note that this is, oh, yeah, that's Greenland, the MALP. Okay, so here we're going west and then north. Um, Here's the ladder. We go west here, and we go north to Little Maze of Twisted Passages, LMTP. LMTP. Wait, that's back to where we were, right? Okay, so that's a loop. So that goes back in on itself. Fine. Um, Great, so let's go north and then west. Oh, so Wumpus is another text adventure? Hunt the Wumpus. Okay. I never finished Zork, actually. What's the one, Dunnet? I finished Dunnet. So that's a text adventure that's hidden inside of Emacs. Um, Wait, this run? I need to use the bathroom, so I'll be back while that's running. Yeah, Memories of Zork 1 and 2. There were 3 games, weren't there? Not that's the same, but did anyone play Angband? I just think of it again because it was another terminal game. That one I did get through. Um, I spent a lot of time in there. A skeletal adaptable maniform. I'm not familiar with those. Oh, you have a friend who plays Angband. Yeah, it's you die a lot at first, and then you learn to play super safe. So what did we do here? We went north and then west. North and then west. A twisty maze of little passages, all alike. So that loops back on itself when you go west. Um, and I assume maybe south will do the same, or north will do the same thing from there. So let's pull up my board. North and then west. No, 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 no. So we're here. You know, let's turn that down my opacity a bit. Um, opacity. Oh crap. Opacity. No, I'm searching. VS Code is lagging so hard. Uh, I swear it's like a worksheet or something. It must be some sort of a worksheet running in the background and just consuming everything. But anyway, opacity, let's turn that down to like 75. Okay. So, we start with a ladder, right? With the bioluminescence, and we go north and then west. So north, twisty maze of little passages all alike. Twisty maze of little passages all alike from here. Yeah, I guess west leads back in on itself. North, we already know where that goes. And, you know, I assume just south goes back. Right. So that just leads back. So let's go north and then north and east. Go north and then go east. I'm gonna need to learn how to like debug VS Code performance and look at what's running in there. Synacor VM sleeper malware activated. You think you might have fired up Angband once? Another beta tester played a bunch of NetHack. You think you saw an Advent streamer playing NetHack the other day? This is a colossal cave. I forget what the colossal cave reference is. Um, this is making me think. Well, these twisty passages I think appear in multiple games, but I think it was first in Zork, right? North and then east, and then what's going to happen from here? So this is not a thing. At this point, we've explored everything, right? This is probably just going to go to another variation of MLTP. That's how we know we're progressing. So I should maybe just preempt that. North and east, we're in a maze of little twisty passages. Maze of little twisty passages. No, we are back where we started. We have to get past the GRU. Wow, it took me a long time to draw that graph. It's not that complicated. Dead end there, dead end there. Okay. Well, fine. Let's go east. And see what to do in a maze of little passages. The passage to the east looks very dark. You think you hear a GRU. Oh, right, so east from there. I think I'd like defaulted to walking east. So we don't want to go there. There's a GRU. But maybe north. You forgot that you need to play Zork. Lost Pig is a lot of fun to play. You replay every time you forget the details. That's nice to forget the details of a game. There are like some games where you can't really replay it if you know the details. Okay, you think you hear a GRU, and we stay away from that eastern passage. Now when you go north, you're in a maze of little alike twisty passages, all little. No, that's different. So MATP. And we'll note our start here. Okay. Well, let's try north from there. I feel like it kind of punishes for taking us the same direction multiple times. So maybe instead we go east. Okay, so after going east, you're in a twisty maze of little passages, all like TMLP. Wait, we've done TMLP, north, south, west. Huh, so that's a one-way thing then. Maze of alike twisty passages, all little. So now we know there can be one-way routes. I wonder how big this is. And I wonder if maybe the next step would be like automating solving a maze in here or something like that. That might be. That might be. Um, okay, so we don't want to go east from there. Let's try going west. Wait, hold on. This is confusing me. Let's undo that arrow because what we actually did here is we went east and then that led to here. Yeah. And I think I've been assuming I haven't tested that going backwards will actually always go backwards, right? So MATP south goes back to MALP. I'm assuming that for now, but I haven't tested every combination of that. So at MATP going east goes back to that spot. We can try north or south. Let's try north. That's the one that seems new. So there's that. Go north, go north. Ladder east, north, and then north. Leather Goddess of Phobos. I don't think I have, but it does sound like vaguely familiar. What is it about? You're in a maze of little twisty passages, all alike. Hmm. Maze of little twisty passages, all alike. Sorry, what was that again? MLTP. MLTP. Wait. That's the same one. Right? Hmm. Well, that's too bad. Well, what happens if we go back south from here? Do we end up back at MALP? Yeah. So let's try south from there. You think here, MALP. This is still MALP. So south from MALP is a loop. Um, well, in that case, we have taken all the straightforward paths. There's a groove to the east. And unless there's like a hidden state, then we've explored everything in here. I mean, we could do a test of our navigation here and see if we end up back at the ladder. Just to test that forward and backwards are always going to be the same. West Passage ladder. Okay, so after the ladder, um, go south, and from here, well, go north, go south, just to test that, and then from here, that brings us to MLTP, which should loop back on itself when we go east. So we can go east, and then let's go south to TMLP. Go south to TMLP, go north, and go back south. Maybe after going south first, we just go west twice. Go west, go west. So north to MLTP, south back to TMLP, and then let's go south to MTLP, back where the ladder is. Go south. Go north, and then go south. You know, I should just set my Emacs environment for when this stuff happens, because maybe I'll have a better experience there performance-wise over VS Code. I'll have that set up as a backup editor next time. And then From here, we can go west MALP, go west. We can go south, that loops us back, go north. From here, we could go south and go back north. And we could go west or north, go north, and we go south, go west, go south. We should be back at the ladder, right? That's just a full test of the cave systems, exploring it, making sure there isn't something funky happening, and we actually have an understanding of the map. Wait, we have so many instructions that were not understood. Things of interest here. Wait, what? Holy shit. Okay, what happened? Huh. I feel like I just accidentally brute forced a solution. There is a there is a code in here chiseled on the wall of one of the passageways. You see a code. Okay, let's sum that one. 5198E. 5198E. Okay. Well, how did we find that? So let's backtrack through this. So we got into the first twisty passage. I assume this game is running on the VMB build, so you have the bytecode. Is there anything stopping you from studying the code to get the graph? Um, no, like we can inspect that. It's just more work than doing this for now. Like to get the graph of this. Like maybe there's like an explicit, it could be modeled in different ways, right? Like maybe there's an explicit table for like some sort of map in memory. And we could look around. I don't know how I'd look for something that matches that pattern, but we could look. Until we really need it. We'll probably do some more kind of principled disassembly later on. So go ladder. And we start falling through the air, moss cavern passage. Wait, twisty passage. So we go down the ladder, right? And then we go south. Or no, yeah, we go south to here. And then we go north to here and back south to here. Maze of little twisty passages. North, south. Okay. So we're back at twisty little passages, which is the very start. So north, south, east, east. Maze of little twisty passages all alike. Maze of little twisty passages all alike. They're still there. Okay. That's a loop, if you can see on the map behind. And then after the east, east, we go south, and then west, west. So if you go south, you're in a twisty maze of little passages all alike. Twisty maze of little passages, yeah. Maze of little twisty passages. Okay, yeah, that's what we're expecting according to the map. and then a maze of twists, and then a twisty maze of little passages all alike. I should just be printing these out as they're consumed. You know what? Let's just do that real quick. This is a little bit silly. You can recreate this. We're doing way too much work. We're programmers and should know better. Go to the VM state. And every time we do a character, we're just going to print it. Yeah, so print character, and it could be a new line, which should be fine too. That way it looks like we're kind of inputting it. Let's still put our map in the background here so we can keep track of that. And our code to the right. You can enter the matrix again and look around. Oh wait, what happened here? SBT server started. Cool. But you're supposed to run main. Yes, the idea is to go south, north, south. So south, which is around the big loop, north, south. And then we go east, east, looping back on itself. South, west, west, looping back on itself. Okay, so from the first twisty passage, see if we're doing that. Wait, where's the first one? Okay. You're in a maze. Nope. We start here. Maze of twisty little passages. So we go south. We go east to MLTP. East still MLTP. Yeah, east still MLTP. So we go south and we end up in TMLP. This one here. And then this should have a loop to the west. So west still TMLP, west still TMLP. And then we go north. That should go to MLTP, MLTP, and south back to TMLP. And we go south back to the beginning. Okay, and then we went north. Why did we go north from here? Oh, just a test. TMLP. Great. And south back to the entrance. And then west. MALP, where there's a group. Oh no, yeah. West is this one here. LMTP. Oh, LMTP. We want west. TALP. Huh. Interesting. So from MTLP going west to LMTP. and then going south goes somewhere. So I think maybe I made an assumption here. This loop here up top loops just back into it, but that doesn't necessarily mean it went into the south side. I don't know where that came from. So north loops back into itself. Let's make that nicer. And then south goes to BALP. That's my favorite one. Twisty alike of little passages, all maze. TALP. My south has turned into southeast over here. Yes, it is my favorite too. You know, you've gotten real deranged at that point, and we are likely to be eaten by Gru. So we went north, and we found the note. We found a note. Is that the note we checked earlier? Yeah. On one of the passageways, we see a note, and then we take note of that and keep walking before we get to the place. So maybe this could have appeared at any point. Like maybe there's a counter of like maze exploration. So in your maze of twisty little passages, all alike. Things of interest here. There's a can. There's one exit west. Huh. We went north from here and found a message. So we went. Let's do that. North. Message just writing on the wall. That's the scribbles. And then we ended up in maze of twisty little MLTP with a can. MLTP with a can. MLTP with a can. And then there's one exit west. I try to go south. I try to go north. I try to go north. I try to go north. I finally go west. And then we're in a maze of twisty little passages, all dimly lit by more. Oh, back to the original. So west gets us back home. So west gets us back home. Um, you know what? I'm not doing it that way. Okay, so west just goes back home. And west is the only option from there, right? We finally like accidentally hit it. And from south we end up in MLTP. That's fine, that actually makes sense. And then we try to go up the ladder. So let's take the can. How did we get down here? Okay, so here's the ladder. Ladder. So we go west, south, north, take can. Okay. So we go west. go south, go north, look can, take can, use can, and go west to go back home, go west, and then go ladder. Okay. Oh, it is full of high quality lantern oil. Great. So now we can go look at the GRU. Can of oil. So where was a bit? We fell down, and then we can go east, go west, take lantern, take empty lantern, sure. Look can, take can, go west, and instead of going ladder, we can go to MALP and then use lantern and then go west. So instead of taking the ladder, when I go west, use lantern, go west. Let's just throw out another go west there for funsies and see what happens. Okay, we're solving it. You light your lantern. Wait, oh shit, I shouldn't have gone west, I should have gone east. So go west goes home, so we go east, and we go east again to find the GRU. Alrighty. You think you hear a GRU, and then we use your lantern. You light your lantern. And then we're still here. The passage to the east looks very dark. You think you hear a GRU. We go east. And we're in a maze of twisty little passages, all like, oh, twisty maze of little passages. Okay. So, getting past the GRU, we end up in a twisty maze of little passages. T, M, L, P. And you can go north or south. And I chose to go east. Great. So let's go north and just go back south. And then we'll go south and go back north just to explore a little bit. Okay. So we go north. Oh, we light a lantern. So at what point did we light a lantern? We go east. Did we not light? We use our lantern. You light your lantern. Great. And then we go east to TMLP. And we go north. We end up in maze of little twisty passages. MLTP. That sounds familiar, actually. MLTP. Yep. So that goes. We'll just join along there. So we don't want that. That's essentially a dead end. Because it goes so far back and you can't backtrack. So instead, let's go south. You're in a twisty maze of little passages all alike. South is a loop back. And those were our only options. Um, this feels fully explored, right? And I think maybe at this point, the thing to do is look at that other darkness thing. So I'm going to say this commented out. Oh, right. We're at least going to take this much of it. Oh, shit. Um, that wasn't good. Okay, so let's take this bit up until go east and use the lantern. And we're not going to go east and use the lantern. We're just going to find the ladder and use the lantern. So go ladder, and then use lantern. And then we're going to go into the darkness. Go darkness. Okay. So, right, you light your lantern. And then you go into the darkness. You feel that your light source is more than sufficient to keep crews away. There are 2 exits, so we're going to continue. All right. You are in a narrow passage. There's darkness to the west, but you can barely see a glowing opening to the east. Um, let's go into the darkness. West. And let's keep going west. Dark narrow passage. And you're still in a dark narrow passage. Keep going west. And see if that actually changes anything. And we found ruins. Okay, so go west, dark narrow passage. There's darkness to the west, but you can barely see a glowing opening to the east. Is east just where we came back from? Is east equivalent to like back here? Yeah, it kind of has to be, yeah. Dark narrow passage, dark narrow passage. Dark narrow passage, and then we are in the ruins. You stand in a large cavern with a huge ruin to the north, overgrown by plant life. There's a large stone archway to the north, acting as a doorway to the ruined complex. A crevice in a rock to the east leads to an alarmingly dark passageway. There are 2 exits, east and north. Well, east is probably that crevice. And let's go north towards that Stone archway. You're in the once opulent foyer of a massive ruined complex. There's a door to the south leading to the overgrowth outside, and stairs to the north which lead into a larger hall. Things of interest here. A red coin. Okay. And there are two exits north and south. Let's look at red coin and take red coin. And south leads to the overgrown outside, and north leads into the larger hall. So we keep going north. Okay, you stand in the massive central hall of these ruins. The walls are crumbling, and vegetation has clearly taken over. Rooms are attached in all directions. There's a strange monument in the center of the hall with circular slots and unusual symbols. It reads, aha. Okay, we have a puzzle. This is our first real puzzle. I mean, I guess this is a real puzzle. Like, the maze is a puzzle. But this is the first time something's actually, like, cryptic, you know? Okay. Blank plus blank. I guess we just get something that leads to 399. And then what do we even... Okay, let's say we solve that. What do we even do with that? Oh, 1, 2, 3, 4, 5 blanks. Okay. I think we found the puzzle that we'll be working on next time. So we made it through the maze, and we can look at that. I'll fix the input stuff offline. And make this a little bit easier to use. But yeah, I think we got 3 more codes today. So we got through the maze, we got through the power on self-test. And we just had to figure out what even is this. So we'll do some exploration around here. But I think it'll be much nicer once I get my input working. But at least there's something to chew on. Well, thank you for being here. I appreciate the support, the debugging, and everything. We're gonna find someone to raid. Yeah, good night. Oh wait, absolutely. I'm enjoying it. I'm curious. Howling Fan Todd's is on. So let's continue there. Back solving some Avena code. It is well past bedtime. I didn't realize I'd get this late. All right. Thanks again. Have a good night.